What did we talk about yesterday? We made a distinction. Hold on. I did use 2 different colors. But I feel like this isn't your booklet. Hold on. This is the afternoon class. Just making sure that you have the exact same thing that I have. There we go. So we made a distinction. So on your study sheet, you want to have this heading somewhere. Dependent versus independent events, or you can call this probability, right? So dependent versus independent probability is probably more applicable, but it deals with events that depend on each other or are independent. So when you have independent events, the question should mention some sort of replacement. If you're actually drawing from a bag, if you're taking out items, you need to be told you're replacing it to know what's happening to that second event. If you replace it, it's almost like nothing ever happened. It's almost like the first event doesn't even make any difference. Okay? Just please pay attention. Coins, dice, or die, if it's just one, those are always independent because you can't remove an outcome, right? Like even if I toss it and I record this, it's still there. It's still part of the coin, right? I'm not removing anything. Versus a deck of cards is different. Okay? If you use a deck of cards and you draw a card and you record it, if you were to place it aside and say, hey, what's the probability of drawing a black card after this just happened? 2 things will have changed. How many cards are left in my deck now if I don't replace this? 51, correct? And how many black cards are left if I remove this particular one? We used to have 26, right? Now we only have 25 black cards. So if the probability of the second card, if that's what you wanted, and this thing has not been replaced, you know that 2 things are altered. The total number of cards for sure, and in this case the number of black cards has also been reduced by 1. Okay, so pay close attention what that first event was. However, so this would be a dependent event situation. If I draw this, I record it, I put it back, and I shuffle it obviously, then we're back to exactly where we were before. So the 52 stays 52, right? The total stays the same. The number of black cards is still 26. Nothing has changed. So with a deck of cards, with marbles, I don't have marbles on me right now, but marbles or students in a class that are drawn out, like if you at all sense any change in the total number of outcomes that are remaining, you know you're in this camp right here, independent, right? Dependent event. The first one affected your second one. Just think about it. If you depend on someone or something, that affects you, right? Like whatever you do, if you're dependent on that thing, it affects you, right? And so the key word is no replacing or replacing if we're dealing with a deck of cards with marbles and so forth. Dice and coins, you can't alter the total outcomes. You can't remove anything here. Okay? The only exception would be if you actually like tossing 3 coins at the same time and you remove a coin after that. That is very rare for that to happen. Okay. Let's go to 50 and just do a couple more questions there to see if you can wrap your head around it, and then I'll just let you work through it. And please do work through it, because if you can understand this, you basically, this is the second last big concept that you need to understand. Okay? And I'll tell you this, sometimes you write a whole exam and this never shows up. Like this concept may not show up on the exam. It might just be a simple probability odds. The probability of it raining is 3 to 5. What are the odds? Boom, you write it down. That's it. But sometimes they do have this in there, so you got to understand this. Okay? So let's look at page 50 here. If a green marble is drawn and not returned, okay, you know that this is a dependent probability situation. What's the probability of drawing another green? Okay, so this is first and this is second. Okay, folks, we are only interested in writing the probability of drawing a green on our second draw. Okay, so this is what we would do. Let me do it a little differently here. I would look at this bag here and I would count, right? 3, 6, 8, 10. So we've got 10 marbles total. Okay. You drew, sorry, so you have 10, and at the beginning you had, how many greens did you have here? You had 2 greens, correct? But the first one is drawn, the green one is drawn and not returned. That means that it affects your number of greens, and it will definitely affect your total number of marbles. So this would be 9, and this would be 1. The probability of the second marble being a green one is now 1 to 9. 1 over 9, sorry. 1 over 9. So you can go back to your bag here and just say, hey, you remove the green one. So we took away 1 to get our 9, okay? So 2 things happened. There's only 1 green left now, and the total is 9. When there's no replacement, the total will change guaranteed. There's no doubt about it. Whether the number of greens is affected depends on what was drawn first. If you had drawn a blue one first, and now you wanted the probability of the second one being a green, well, obviously only the blue ones would have been affected, which here in this work would have only meant that my 10 turns to 9, but the 2 would have stayed 2 because, right, the blue drawn first doesn't affect the number of greens. So just watch out for that and just practice this, okay? Next, if a blue marble is chosen first and not replaced, what's the probability of a red marble? Oh, sorry. Curveball, sorry, I'm rushing here. Blue marble is chosen first. That's gone. So we can go here. Boom. Then a green marble, so first, second, so 2 events happen. Right? A green one is also removed. And they're both not replaced. What is the probability of drawing a red marble on the third draw? And here it is. You're left, you had 10, you removed 2 marbles, you're left with 8. So this would be 8. And you want a red marble, correct? There are still all 3 original marbles that are red are still remaining. So this would be just 3 over 8. Okay? And so forth. So you just got to read what happens first, and then whatever remains, that's what you use to set up your fraction and set up your, state your probability that way. Okay? So I will tell you this. Pages 50, I wrote this down here, 1 second. Did I do this in the front? To 53, okay? Pages 50 to 53 deal with this topic, this concept, okay? Try to, if possible, get right to 53. If you're done, I'm not going to stop you. Anything past 53 is kind of review material already. So, no, sorry, 54 is expected value. So, sorry, I will tell you, if you're in that boat, I'm just going to double check if we're doing okay there. No, you can keep going. So if you, I'll get it right to you. If you finish 53, you can keep going. There's nothing new under that, but it's just different review material to get you into the groove of review, okay? But for now, 50 to 53 is what I want you to focus on. All right? Thank you, guys.